this lesson, we will show collaborative robots working in several different industries, completing several different applications. One of the most common uses for robots is in material handling, ranging from very light payloads to very heavy payloads. To date, collaborative robots have been used in material handling applications with payloads of up to 30 kilograms, although at heavier payloads they are restricted to moving slowly. Most applications are for payloads in the 1 to 5 kilogram range. The automotive industry is one of the most heavily automated industries with a lot of heavy, dangerous jobs such as spot welding, spray painting, and palletizing performed by large, powerful robots. The automotive industry has also been quick to embrace collaborative robots for lower payload applications, including some in which the robots will work together with people. Robots continue to find new applications. Recently, the life sciences industry has started using robots to automate testing and drug discovery, and there are now thousands of robots working in laboratories around the world. The electronics industry has automated the assembly of printed circuit boards, and now robots are beginning to be used to load testers and sort tested boards. Robots are also assembling consumer electronics products such as smartphones and disk drives. Finally, we will show an example of how collaborative robots can reduce floor space in factories by mounting directly onto existing conveyors and eliminating large control cabinets and safety screens. Earlier, we spoke about zone sensors, which monitor an area by sensing when people enter the area and slow down the robot if a person gets too close. In the following video, you can see an example of this approach to converting an industrial robot to a collaborative robot. This collaborative robot can handle a payload of up to 30 kilograms. There is a large force sensor between the base of the robot and the floor. This force sensor records the normal forces during a training session. Then, if during operation, an unexpected force is detected, the robot will stop. The force sensor and controller also support a mode where the operator can push the robot around to teach different positions. As payloads get heavier and robots get bigger, they must move more slowly, down to speeds of a few hundred millimeters per second in order to work in a collaborative mode. This is an example of a person and a robot working together as a team to install shock absorbers in the wheel well of a car. The person loads the shock absorber onto the robot, and the robot reaches up under the car and drives screws into place to attach the shock absorber. This team approach greatly reduces the stress and fatigue for the person, but avoids the fairly difficult process for the robot of picking up the shock absorber and inserting the screws into the bracket prior to installation. In this transmission manufacturer, a collaborative robot was recently installed to load parts into an automobile transmission. In the video, you will see a worker delivering trays of parts to the robot, and you can see the robot stop if it bumps into the worker. No safety screens are required. In this video, taken at Volkswagen, a collaborative robot aids a worker in assembling an electric motor armature, while a second robot does some material handling, loading and unloading the armatures from a conveyor. Here, we have a work cell for pharmaceutical research in the life sciences industry. In this work cell, the instruments can cost hundreds of thousands of dollars. So not only is there a benefit in protecting the technicians who load the work cell, but if the robot bumps into an instrument, it does not damage the instrument. Note the kinematic configuration of this robot with a horizontal arm and vertical tower, which allows it to take up a very small footprint in the work cell. It is still able to reach into, around, and over the various surfaces and trays in the work cell. The robot makes a number of complex motions to orient and reorient the sample trays as they move around the work cell. Circuit board testing is a common application in the electronics industry. Many circuit boards are made in high volumes for consumer products, and the assembly of these circuit boards has been largely automated. However, Circuit board testing uses a variety of fixtures as well as testers. Most are loaded manually. In this video, you see a collaborative robot with a vision system in the gripper that can locate a circuit board, pick it up, place it carefully in a tester, and then close the lid on the tester. When the test is complete, the robot opens the tester, picks up the circuit board, and sorts it based on the test results. In this factory, all the testers were clamshell testers, designed for manual operators. However, the robot is able to open and close the tester just as a person would. Here's another life science application in which two robots, both mounted on linear rails, access a large working volume. The cell has storage on one side and racks of expensive test instruments on the opposite side. There is an access aisle down the middle of the cell to allow people to service the equipment. In this case, collaborative robots were chosen primarily because of the cost of the test instruments. Industrial robots, which could access this large volume, would be way too powerful if there was a collision with an instrument. Note also that in this application, the robots hand off trays between the two work cells and must avoid working in the same area at the same time. Note also the large vertical travel of these robots results in a very small footprint. One of the characteristics of these particular collaborative robots is that they have the controls mounted inside the robots. There aren't any external cabinets full of controls and cables. This allows the robots to be attached directly to conveyors and even mounted over the conveyors, thus greatly reducing floor space, as opposed to a larger floor-mounted robot with a large cabinet full of controls. In this video, we see a pallet conveyor with zone control. The conveyor is divided into 750 millimeter zones and pallets that can move from zone to zone. The pallets can be stopped and elevated so that other pallets can continue underneath them. This allows asynchronous timing of operations on the pallets without the need to remove the pallets from the conveyor line. For example, if one operation takes 10 seconds and the next operation takes 5 seconds, pallet stations can be assigned so that 2 can handle the 10-second operation and 1 can handle the 5-second operation. This avoids pulling the pallets off the line and creating extra work cells for the longer operations. As factory floor space is very expensive, the ability to eliminate large workstations on either side of the conveyor is very valuable, which is made possible by compact collaborative robots. This ability to design so-called lean automation work cells is demonstrated by a comparison of a traditional electronics robotics assembly line with a lean assembly line with a pallet conveyor with clip-on collaborative Cartesian robots. The traditional line has large cabinets around each robot in which the bottom of each cabinet is filled with controls, and operators are protected from the robots by expensive enclosures. The lean line with collaborative robots eliminates the bulky cabinets, and the controls in this case are located inside the robots. The lean approach greatly reduces factory floor space and cost. Different processes can be mounted on the collaborative Cartesian robots, such as screwdriving, dispensing, assembly, and loading testers. In addition, people can be interposed among the collaborative robots. For many products, there are some very difficult tasks, for example, wiring. With a collaborative robot approach, people can sit at stations to perform demanding tasks, and the robots can be placed next to the people to perform simple and boring tasks. The intermixing of robots and people means it is not necessary to automate the entire line, which greatly reduces the time, engineering, expense, and risk that comes with installing robots. In conclusion, collaborative robots are quickly gaining acceptance in a number of different industries, and they are reducing the cost and risk of installing robots. Collaborative robots are often viewed as friendly machines by the people who work with them, and in many factories, they are given names and considered co-workers.